Hello and welcome to Elixir Berlin 75 edition. Thank you for joining us. Uh, for those of you that haven't seen our live stream before, just want to do a quick recap. We have a live session, as you probably, if you are watching this stream, it means that you already get access to the YouTube. We also do Q&A and discussion in the Discourse channel, which you can find our Discourse channel in the link here. I'll just give you a few seconds if you want to copy the link to visit the Discourse channel. For today, we have two main tags and one probably lightning tags. Still, the lightning tags had some issues. We're still trying to mix the audio and video together. Let's see if we can manage to create the final version by the end of these two tags. So the first one is by Yatender. Is going to talk about distributed tracing Elixir, and then Hermina will join us and he will give a talk about being better parent to your children. So without further ado, let's start the first one. Have fun.
Hi everyone, today I'm gonna talk about distributed tracing in Elixir with Zipkin. There are other ways to do it also, but today I will be focusing just on Zipkin and OpenTelemetry. So let's go ahead. So agenda for today would be that we will get to know about what is distributed tracing, what is OpenCensus and OpenTelemetry, how you can set up OpenTelemetry into your application. And then we will be doing some code and we will check that how the trace looks into Zipkin, and then we will do some demo. So I'm Yatender, and I'm here because I love Elixir like you, and you can find me at Yatender OK Talk in GitHub, and I am working in Elixir from last 4.5 years. So like it's been quite long since I'm working. So let's without any delay go ahead and check what is distributed tracing. So you can say it's a collection of data related to end-to-end request within the multiple microservices or multiple systems, as you can say. So distributed tracing is nothing but it's a method to profile and monitor applications. So you will be seeing all the details related to a particular request, that how did it flow into your particular microservices and how the request flow was, and where did the things went wrong, and what was the response time, what was the properties. So all the things you can get to know via distributed tracing. So before that, let's talk about the previous systems, that how it was and what was the need to develop it. So as you know, previously we all used to do monolith systems where there was only a single code base which was deployed, and if we want to uh, scale, then we has to put the multiple copies of it behind the load balancer. So it was like very easy to develop, easy to test, simple to deploy, and yeah, scaling was also easy. Whenever any request used to come, request will just go to load balancer. Load balancer will take the decision that to which copy I should send the request, and then it would do whatever it has to do. Either it might talk to our DBMS or any database or third party, and then it will just respond back with the necessary response. So as you know, as we just discussed, that any user will just come and do request. So request will go to the cloud, then the load balancer and the monolith and the database, and then in the same manner request will go back. So this flow was like very easy and very simple to debug, develop. But as you know, as time passes, there was some need to do it, because there were some, of course, drawbacks was there, because applications maintenance was a problem, because became very complex, and if there is any problem in a certain piece of code, it was very hard to make changes in it, because it was dependent on many teams, and if something is wrong, it will take down the whole system. So yeah, of course, we came to microservices. As you know, right now most of organizations are like that, where we are responsible for multiple services. It has some developers, it has some leads, and someone is managing the whole product, or there might be multiple product managers also. So yeah, it enabled us to for continuous delivery, deployment, and we can build a very large complex of applications over here. Eh, it's better for testing, deployment, because if something is down, it will not take the whole application down. It might take a couple of services or any services which is dependent on that particular service. Apart from that, the system will keep working fine if your things are in place. Yeah. But what was the problem? As you can see, the request will flow into multiple applications. It will come into cloud, then we will put the load balancer. It will go into microservice one, and let's say then we have to communicate with the multiple microservices so the request will flow over something like this. It might be a very random order where it is very hard to debug. So there are like loss of coherence was there, and it was very hard to debug, troubleshoot, all things is very tough to do over here. So as you can see now here, the flow of request is not linear. It's flowing between the multiple microservices. There are service A, B, and C, and there are multiple requests flowing. As you can see, request is flowing between the service A to B, B to C, then request is coming, response is coming back from service C to B, and then B to A. Then there is a lack of linear path, and it makes a very hard to track the request flow, and we don't have any data about what was the request ID which was flowing into multiple applications, what was the time taken. This is doable, but it's tough. It's tough compared to a monolith application, we all know. So yeah, so distributed system right now made up of like multiple microservices and are like more complex entity in itself. So to solve this problem, we introduced OpenTelemetry. This project aims to solve this problem for library developers, and it's a vendor neutral tracing API which comes with no dependency, and yeah, it's quickly gaining a support from a large number of monitoring systems. Right now, OpenTelemetry Uh, OpenTelemetry provides a single set of APIs, libraries, agents, collector, and very services are there. Multiple services are there, and yeah, we capture the distributed traces, and yeah, we can see into multiple applications like Zipkin, Honeycomb. There are many, so it's up to you which one you are using. There are some terminologies related to OpenTelemetry. If we know, if we know about them, so it would be good. Let's go through it one by one. So let's go to span. What is span? Span is created by multiple instrumenting your span is created by instrumenting your application and their libraries, and it's a primary building block of distributed trace. Yeah, it has some details like operation name, what is the timestamp, start and finish. There will be some attributes like list of key value pairs, and yeah, there are like multiple details will be there through which you will get to know that what was the time taken, what was the name of service, etc. There is a trace is composed of like multiple span, and trace is a single unit of work, you can say. Like a request will leave one trace, and one trace will be having a multiple spans. Yeah, so if you see a trace in your application, so you will see there will be a trace as we are seeing over here. A is a trace transaction, B is a response from the microservice, and C is another span, D is another span, and E is another span. So span B, C, D, and E is composed within a trace. You will get a trace ID, and as soon as you will put into Zipkin, you will get all this kind of data, which we're gonna see in like some time. So let's get familiar with the span context. Span context contains four information: trace ID, span ID, trace flags, and trace states. Trace ID is a 16 byte randomly generated digit which will be particularly unique, and span ID is 8 byte random number, you can say, or random ID. And trace flags and trace states contain state related information like key value pairs and other states, which will be helpful in propagating the span context. Yeah. So OpenTelemetry is nothing but it's a merger of Open Tracing and Open Sensors, and it has multiple libraries already there: OpenTelemetry API, OpenTelemetry Zipkin, Exporter, Acto-Li, and everyone is moving towards in that direction, and it's available in four other languages also. So yeah, it's so let's get to know about the collectors. So collector is something which collects the instrumentation data, and then it pushes into a storage, and yeah, then it provides you API, and it provides UI also, so that you can just query and check your logs and details. Zipkin has storage, collector, get your data, and you can do processing over it. You can just uh, make it whatever you want, and then you can just put storage. Initially it was built to store into Cassandra, but there are multiple plugins available, so there are like multiple options for storage also. Then it provides a API where you can search your logs, and it provides web UI also, so we will be seeing just now. So let's check how to add the OpenTelemetry into your project. It gives the You can just add the libraries. First of all, you have to find the libraries, of course, and then after finding the libraries, just add it into your application dependency. Here I'm adding API, Zipkin, and OpenTelemetry. Then you have to just register your application with the name. Here I am registering my application as alpha, as you can see on the line number 4. Then you have to tell the what will be the service name for collector. Right now I'm using OpenTelemetry Zipkin. And here, when you want to instrument a code, or you want to trace a code, so you just have to wrap like this. And right now I'm doing OpenTelemetry tracer. Here is the span name, alpha span. And then I'm adding some delay just to mimic that it's doing some work. Then I'm calling some operations like setup data, perform call to beta. Beta is my another application where I will be doing some work, and which I will show you just now. So if you want to communicate between multiple application, which was the agenda for today, so you have to pass your current context. As in the image above you can see, I am checking what is the current span, and I am storing in a span context variable, and then I am doing an RPC call to beta. Beta is running in my local host. It's another service, and I am calling the get account info method over here. I am passing some params, and yeah, span context also I am passing as a parameter. And the down image you can see get account info method is there. It's getting the params and parent span, and it's starting one more span, which is beta span, and marking the parent span, which is the previous span context, as the parent of the newly started context beta span. Now it is doing a RPC call to a Charlie. Charlie is a third application in my system which is running right now, and it has a get account method. And here also I am passing the params and the current span context, which is I'm getting just now. And yeah, so let's see the demo, and let's understand it better how we. So now let's start the demo. I have three applications configured with the OpenTelemetry. I have Alpha, Beta, and Charlie. So in short, let's go through one by one how I have configured, and then we will see like how does it work, and how does distributed trace looks. So as you can see, I have added three libraries: OpenTelemetry API, OpenTelemetry Zipkin, and OpenTelemetry. Now I have to register this alpha service with the name, that what will be my application tracer's name. It can be anything, it doesn't have to be the name of application, but for simplicity I have just kept it alpha. Now you have to tell your collector, which is Zipkin in our case, that what is your local endpoint service name. So it will be alpha. So when you will see the traces in the Zipkin, it will be coming as a name alpha service. Okay. Let's go to beta. Here I have also done the same. Service name is beta. In the applications, let's see, the register tracer is beta, and likewise the dependencies are all these three only. And same likewise I have done for Charlie, so let's not go in it. So in short, what I have done is I have created one simple method where I will be having I will be requiring the OpenTelemetry tracer. It's important. Then I will be starting a span, as I have already shown you in the presentation, that whenever you start a span you have to give a name. So just to make it simple, I have kept its name as alpha span, and whatever operation we want to do inside it, we just wrap it around the span. Or we have another API, start span and end span, that also we can use, but it's up to us. So to keep it simple, I have kept it inside the with span. And yeah, so this was the parent span, and it was not having a parent, so it will not come anything. So what we are doing over here, I am just mimicking the delay, or like it is doing some operation. So as you can see, I'm setting up the data and I'm adding some delay, which will be like 100 millisecond, and I am just making our process sleep. So it will mimic like it took like 100 millisecond to set up data, and then we will be performing a call to beta. So beta is our another application I just I've shown you. So we will be doing a call to beta, and in that call we will be passing the span context. So to propagate the information of the current context, we have to check what is our current context and then pass it as a parameter. Right now I am doing an RPC call. We could have done the HTTP, but I have not done that. So I have one application running in my local host called beta@localhost, where I will be calling its get account info method. So let's see what it is. So let's go to beta and let's go to get account info method function. Here as you can see, I have also required the OpenTelemetry tracer. Now I am starting a span, and span name is beta span, but here as you can see, I have given a parent of beta span, which is like alpha span, which we started in the alpha application. That this is the parent spans information, which we are setting it over here. Whenever we start a span, then we will get the info of the current span, which with a new span which will get started over here, as you can see. So whenever we will get this context, so it will give information about the context of beta span. Then here we are doing an RPC call, which is to application Charlie, which is also running in our local host, and then it's calling a get account function over here, and we are passing same the span information of the current span. And then let's see what is there in the Charlie, and then we will run the demo. So here also we have get account function. We are also starting a span, which is name is Charlie span. We are adding the data of parent, that this parent span which was coming from the RPC call is our parent. So what it will do, it will make Charlie span as a child of beta span, which is over here, and and beta span will add alpha span as a parent of beta span. Okay, so enough talking. So let's run the application and see how does it look, how does it work. So I will just make it smaller so that you can see all three. So if you say, we will be starting s name beta@localhost to do the RPC call properly. Here we will be doing the Charlie, and here we will be starting the alpha. So alpha, beta and Charlie, three applications which are here. So we will be doing an RPC call from alpha to beta and beta to Charlie, and then Charlie will respond back to beta, and then beta will respond back to alpha, and in the end we will be seeing one trace which is having three spans in it. So let's see how it goes. And yeah, so it's an alpha dot start call. Yeah, so let's see how does it look. This is the older one, so let's go to discover page. This is our discover page, and we will check like what all events we have got in last 15 minutes. So we have one event, and let's go inside it. Wow, so as you can see, we just got an alpha, beta and Charlie. So this is alpha span, which took almost 395 millisecond. One is beta and one is Charlie. So Charlie, as you can see, Charlie span ID is this and parent ID is this. Parent ID is the span ID of beta, Yes, I'm correct. And then this is the parent ID of alpha. Alpha is the root span, so it will not be having any parent ID. So yeah, so now if you want, we can add more properties in the tags, which you can see show all annotations, and then hide, and then you can see all the tags related to it. So it's like you can get quite a lot of data. It's up to you what are you tracing, what are you doing. So yeah, all that you can do. It's up to you. You can just play with the library a bit, and then it will be like good to go. It's quite easy, and just give it a try. So here was my demo, and yeah, I will be finishing. Thank you so much for listening to me. uh, Yep, and yeah, this was my demo. Thank you so much. Hi everyone. Let me know if you have any question. I would be happy to answer them. Okay. In case anyone has any question, please post on the meetup group, and I would be happy to help. Thank you. Okay. So the question is that does OpenTelemetry have any API to query data or only UI? So OpenTelemetry doesn't provide anything to query data. You can query from the Zipkin. It provides both UI as well as API. So if you pass any trace or any related to span, so it will give you very nice UI plus both API data. So you can either create your own dashboard, or you can utilize Zipkin only. And any preferences between Zipkin, Jaeger, and Prometheus? I have used Zipkin and as well as Honeycomb a bit, but more experience I have in Zipkin, and it's pretty good. I have not shown you everything over here, so you can use it via telemetry. Telemetry and open telemetry are different thing here. So with the combination of telemetry plus open telemetry, you can add a very beautiful key value pairs over here with the tags. So and act also provides all the data. So if you use it with the telemetry, so all the telemetry events you can just push into open telemetry also. So everything will be shown into the UI of Zipkin, that how much time it took for you to query something in the table, how much time it took for you to call the third party API or anything. So it's like a very nice. Uh, I would say you should give a try with this telemetry also. And are there any other tools like Datadog, for example, that can be used as a UI for this? Actually, you can use with the Datadog, but we don't have any exporter available right now. Here I have used a Zipkin exporter in the demo. If you have exporter for Datadog, so you can use it, but personally I have not seen yet. Maybe it's in under development. So if you find, yeah, you can use it. It just open telemetry just stores the data in the required format, and via the exporter you can use anything. Yep. uh, I guess I have passing the parents make the codes ugly. What have done in practice to make it code nice? So yeah, so I was just shown you like what is necessary to you to get the distributed trace. It's up to you. If you are doing any HTTP call, you can pass in the headers also. You don't have to pass in the parameters. So, you can write your own meta program where you can just annotate the method and it will just do it for you. Or you can also write the interceptor. Yeah, so it's up to you. It's like very easy things to do once you start grasping the things like how things are working. It's very easy. I just to demo like how it's getting passed into the child spans. I have shown you like this. Otherwise, yeah, I know it's ugly way. More questions? Okay, thank you so much, everyone, for giving your time. I hope you all have got some idea. Okay, thank you so much.
Hi everyone. I need to say thank you for the Berlin Elixir community to open space for I present my talk. And yes, my talk is talking about to be a better parent to your children. And who am I? My name is Emilio Torres. I'm a software developer. Basically, I use Ruby and Rails as my main language. This is my contact. Feel free to send me a message or talk with me for everything, your thoughts, or uh, be free. Feel free to let me talking about anything you want. So we need to setting our expectations, uh, things we need to know, process. We need to know process in Elixir as well. So yes, how to start process, and send message and something like that. I presume in some point you know how doing this thing to manipulate process. Yes, implement the Gen server as well as your client server for create this interface for your applications to handle your process, send message, receive, and do anything you want in your applications. Not on that, but know about supervisor, supervisor tree, how the process supervisors doing some strategies for restart your process when they crash, stopping, and no matter what. And yes, need to this stuff about supervisors and ETS, or long-term storage, like key pair of air for storage. Uh, yes, no, you want what no matter what, you know. Uh, and let's go and find out. So when we talking about PAD, I start some process and something like that. we has this thing identification for our process. And imagine we have this module call it secret server. It's my server. It's an implementation for this behavior agent server. Likewise, I said before, things you need to know for comprehensions very well about what we talking about this talk. And yes, I have this function. It's start link. It's API for our joint server for start our process. And yes, I need to say what kind of the module I would like to start this process. And yes, initialize uh, with some value for initialize our process. And basically, I pass the name for our agents for start our process. And the name for my agent, I choose James Bond. Yes, as you can see, when we start our IX sessions, and I use my module and start my process for my uh, agent. And yes, I press my James Bond and grab this uh, feed for if I would like to interact with my module in the future. I need to grab the speed for send message with yes, pass, change, anything I want when I would like to interact with my process, change the states, and know what kind of the current state and so on. And yes, and what about the pit? It's hard to remember the number of the process, and each time the process crash or stop, when we start, we need to save again a new pit, you know, and it's very difficult to uh, keep the storage and knows this process, what kind of this process means, represent, and the PID, it's keep it alive or not. And we need to check in. And yes, we need to create code, create some code to provide us this thing. And if you think about when you use the PID for send new states, consume the state, change the state, and so on, when you interact with the gent server, uh, it's very hard. Remember when you use the PID, it's the same way. Uh, when you imagine when you like to access the Google, and yes, anybody, I think, open the browsers and uh, put right this IP address for access the Google website. And for this thing, we could use a module for naming our process when we initialize uh, our process. When you can see the for line, I name it the process when we start. So it's the same way, but now when I start my process, I don't necessarily keep this PAD because choose use the name for my module. So when I try to start a new process, I receive this topo message and wait, this process is started, already started because yes, we put in a hard code to use the name for the module. And when basically if you need to say a new name for new process when you like to you starting a new process and something like that, so uh, yes, we can grab the pin using Gen7 wires and pass the naming for our process. And if you think about it, when we choose use module, it's easy to remember because it's the same way like use DNS for IP address and something like that. But the problem, yes, we need to only one process uh, using this approach. And the other options use atoms. So instead use the name of my module to start any process. Yes, I pass the name for the agents and I create this function to doing some transforming for the name for my agents for return atom for I can initialize my new process use this name. And for uh, yes, I use these transformations. Likewise, if you think about when I use Mr. White, it's a villain for James Bond. And yes, when I send this Mr. White, the output for me is Mr. White as a atom, and basically I remove the entire punctuations, down case, and join the the entire name using underscore and return as an atom. I can initialize my process passing the name of the villain, Mr. White, and yes, if I try send start a new process use the same name, yes, probably for sure the VM tell me is the same thing. It's the process is ready because I use the same name, but it's uh, you can use another name for initialize new agents like James Bond and something like that. It's the way I could grab the PID for my process, passing my atom for the server to grab the PID for the respective process. And yes, like I said before, I could initialize a new agent pressing a new agent like James Bond. And okay, atoms. Atoms is the same approach. It's very easy to remember because we use name for uh, naming our process. Is you probably could use for initialize many process as you can, but the bin has a maximum size for handle it with atoms. It is this number. If you extrapolate this number, probably your bin is crashing and your entire system is going down. Okay. Uh, but from because these limitations is the better way, uh, not only avoid use atoms for initialize our process. The garbage collections don't remove atoms if you think about it. And as I say, we start this entire uh, path uh, starting when we use PID, the name of the module, atoms. Uh, yes, we has the same issues. How we keep uh, the integrity for our process. I would like to some place for keeps this info like the name for my process, the PID, and so on, and need to know uh, how to handle with that. It's using Hezron module. The developer and join the Elixir after 1.4 version for Elixir. Is this is a concept for registry. It's a local, decentralized, and scalable peak pair process storage. It's allow us to look it up one and more process given only the key. And yes, we can see the same approach when we use the ETS for storage, because ETS use a key value storage approach. And yes, each entry in our register is associated by process, and yes, we have this key for registration and represent our process. And no matter what, each kind of the process crash or stuff and something like that, basically we uh, automatically remove the key associated with this process where we use. We could use for initializing registry the name for the process using this technique like via topo. Is basically because we need to uh, via tuple as a key value pair for uh, saving in our storage in registry. And not only that, we need to use atoms for naming our process. Is the best approach we can use when we need to start in keeping the tracking for our process is running in our VM. Yes, we could use as a dispatch, uh, not only that, but as a pub sub too, and for registrations, and yes, like ATS as well too. And how we use uh, this thing in our supervisor tree, we need to put this information. Basically, we need to pass for our supervisor, initialize a registry. We need pass this unique keys, but if you would like to, you could use duplication keys. Not on that, we naming our registry, naming the our storage uh, is a secret dot registry. And yes, we need to change our approach for initialize our process, and I create this function call it via tuple where I receive the name of the agent, and the function via tuple receive the name of the agent. And yes, we has this tuple and call it via passing for our registry, and we need to pass the naming for the our registry and the name of the our process where we would like to initialize. And I have this API interface, call it this function, call it echo. And basically the echo, I pass my uh, naming for my process, call it James Bond, and pass this message. My name is Bond, James Bond. When I use this function, for sending this call message for my uh, server and return this string. James Bond say, my name is Bond, James Bond. I could initialize my new process called Mr. White and another initialize called James Bond because uh, they are animated in 007 movies. And when we observe our supervisor tree before I start any process, basically the supervise initialize are dynamically supervised, and not only that, but initialize a registry, and basically the registry use the same approach, use a gen server for uh, your background, and the implementation in Gen server use ATS for create this storage, and use to registry our naming, and yes, in keeping the tracking and following, and initialize our partitions, new partitions where I define in my supervisor tree is a secret registry. And when we see in table view, we see three entries for our registry, our secret registry, and basically our secret registry has two entries for our partition 0 and key 0 and PAD 0. And basically when we open this key in partition, we can show that we initialize a process, call it 007 for our agents, and this our PAD. And yes, when we initialize our process, basically they put this data in our registry storage, and yes, we can see in observer the link is this blue line, and linking in our table a reference, the key for reference for this P. When something's going wrong and our process is stopping working and something like that, or reinitialize crashing something, when we starting again our process or supervise as starting using our strategy for initialize the process, is automatic key. Basically they use the same key and link for the new PAD process. Yes, because we use this approach for via tuple when we need to grab the PAD for our process keeps it alive, and we need to use this function via tuple and pass the name for our process to grab the PAD. And the PAD partition and key partitions, as I said, when I initialize these two new process, Mr. White and James Bond, we can see in key partition and PAD partitions, we have these two entries to keep this tracking in our registry module. And this the way we can could use in IX for concealed the keys for our registry and passing the name for the process. And yes, we return is the same thing we can see in Observer. And yes, we can use the looker up for our registry as well too. It's the same thing. We can see in PAD partitions and key partitions as well too. And if you think about it, when you use ATS and interact with ATS, is wrapper. It's looker up is function for this API we use Hazardry for interact with in the background sign is using Agent Server and ETS as I said before. And yes, thank you everyone. And is this uh, hi everyone. It's time for a Q&A. If anyone has questions for me or things, thoughts, anything you want to share or say so, I would like to know. And yes, for the record, I completely forgot before, but I looking for a job in Elixir. And yes, at time I living in Fortaleza, Brazil, and yes, I use Elixir for 5 months in the row. I most take some classes for Agroxio, Blue State, and to help me out to bear improvements and learn very fast Elixir. Uh, Hene, okay, Hene, you could use registry in your Phoenix too. You know, it's independent specific project. It's for Elixir project. Phoenix is Elixir project for the end of the day. And yes, you could use registry for keeping tracking your process. You know, basically you need to declare your registrations, naming your registrations, and your boundary context when you like to create your uh, library for provide in Phoenix for APIs. Would you like to you starting or client web server or web entire web and this thing you could use, you know, not only for CLI or Elixir. If you like to know more about the documentations, it's a good step for C and how it works, how you could use your projects, and you could use Registry for PubSub like a channel. Yes, I have this gaming, and the game has this room, and basically I could use Hazard for something like some approach, and someone assigned this pub sub, and you could use some strategies for your registry. The registry can communicate the other process. It's alive. It's tracking for your registry, and you could implement some agent server function for send some broadcast for everybody in chat in your gaming and say hello for Rene this jumping right now and something like that. You could use registry for send dispatching for your chunk, your mailbox for delivery mails. It's a good one. Yes, ETS is key pair, and so basically you imagine like a Redis, you saving a key for you can get this value you would like. ETS is for this is a storage in memory, not in memory but in VM, a bin VM. But yes, it's the same thing. I don't know the limitations for ATS. Okay, uh, I think I answer the questions for Renee. If I don't, let me know. And for the question for Hugo, basically I use registry when I studying Elixir and this thought, this part, as I like to initialize uh, my process, and I don't think like as well uh, use uh, atoms and basically for learning I don't use yet for in production case. So Renee half tells ETS has limitations like memory you set for the bin VM. Thanks, Raf. Yes, Raf. It's it's the sun. In Fortaleza, it's afternoon. In here, it's 3 p.m. Right now. I live in Fortaleza, Brazil. Any more questions? If not, I will stop uh, sharing. I feel glad to participate the Elixir in from Berlin meetup. It's it's cool. It's cool because it's online. It's the only way I can participate this thing. I basically see in meetup many meetups in present, and I don't travel yet again, and, and maybe next year we see and face together in present, and I sent some talks from Berlin meetups. I hope. Thanks, folks. I I will stop right now.
Thank you everyone for thank you for the for thank you to the speakers. It was a really great talk, and thank you for joining us in this online event. And I hope that you have a wonderful evening, morning, afternoon. We are going to stay online in the discourse voice channel. If you have some more questions or you have some thoughts you want to share, you can find us there. Yeah, that's it, and I hope to see you next month.